Hello, everyone. All right, so with this lesson, this is going to be called Systems of Inequalities. So on this one, we're going to be bringing back our graphing equations, and we're also going to be bringing back just inequalities in general with shading. So there's kind of a good amount that goes into this lesson, but a lot of this is actually going to be a review and just a consolidation of what we've already done. So we're still kind of bringing in the aspect of systems. So we're bringing in more than one inequality. So we're going to have two or more inequalities with the same variables. So instead of our solution being a point, our solution is actually going to be a area or a sector or a portion of the graph. So first off, I gave you these two different systems of inequalities, and we want to determine which ordered pairs are going to represent solutions. So for it to be a solution, as mentioned before when we did inequalities, it has to be in the shaded area. So looking at this first coordinate here, we have 0, 0. So if I plot that here on my graph, that is within the shaded region, which means 0, 0 is a solution. Now if I go to 4, 2, that's not in the shaded region, which means 4, 2 is not going to be a solution. Then if I do something similar with -3, 0, plot the point, it's in the shaded region, it works. Now, if I do -2, 4, that would be up here on the solid line, which means if it's on a solid line, that works. Conversely, if we're going to do 2, 3, which is on the dashed line, that one doesn't work. Because remember, a dashed line means we cannot be equal to it. However, a solid line, we can be equal to it. All right, so now looking at this next one over here, same idea. So I'm going to go through this one kind of quick. So 0, 0, it's right here at the origin. It's not in the shaded region, not a solution. 4, 3, which is way over here in the corner, kind of not, it's on a solid line, but it's not in the shaded region. So that's not what we're looking for. -3, 3, it's on a solid line that connects to the shaded region, which means that one is a solution. Now looking at -2, 4, that point is well in the shaded region, so that one works. And then we have 2, 5, which is on a dashed line, which means it does not work, which means we cannot be equal to it. So our only points that work are those two. The rest of these do not work. All right, so now looking below, we want to solve each system of linear inequalities by graphing. All right, so this is just like graphing a inequality from before. So I know based on my first equation here, I know my slope is going to be equal to 1 because it's the number in front of my x value. And then my y-intercept, which is my b value, is going to be -4. Now, based on my inequality sign here, because I'm less than, that means I'm going to be below, and then because we cannot be equal to it, that means it's going to be dashed. So we have a dashed line, and it's below. All right, now for our other equation, so I actually recommend using a different color, just so you can see the shading. So same idea, I'm going to do my slope, which is -1, and my b value, which is +3. Now looking at my inequality sign here, I can be equal to it, which means that it's going to be solid. And because it's above, it's greater than, that tells me I'm going to shade above. All right, so just real quick, just in case you need a quick reference, I'm going to do the quick reference inequality sheet or the chart. I'm going to use a Punnett square. I can draw, everything's fine. All right, so greater than or equal to, greater than, less than or equal to, and less than. All right, so for the first column, that means that we have a solid line. For the second column, that means we have a dashed line. And then for the first row, we shade above. And the second row, we shade below. So if you ever have a less than or equal to, it's a solid line, and you shade below. If you ever have greater than, that means it's dashed and above. All right, so if you have less than, it's going to be a dashed line shading below. So just kind of a quick reference or quick idea of how to use this chart. All right, so I'm going to use my purple for the top equation. So remember, when you're graphing, you have to start always with your y-intercepts. So I'm going to start at -4 in purple. So I'm going to put a point, and then from there, I'm going to apply the slope, which is 1, which means I'm going to do the slope of 1 over 1. So 1, up 1 over 1, up 1 over 1. So up 1, right 1, up 1, right 1. All right, and that is a dashed line. So remember on Notability, you have the ability to create a dashed line. All right. So there's the purple line. Now we want to be able to do our equation in green. So for our equation in green, I'm going to start with my y-intercept of 3 and then do a slope of -1. So I'm going to start at 3 and do a slope of -1, which means I'm going to go down 1, right 1. All right, so remember, for a system of inequalities, we're not looking for the actual point of intersection. We're looking more for an overlapping shaded area. So now if I do my purple line I'm shading below, which means I need everything on this side. This is not going to be as pretty as I had hoped, but everything's fine. If I sit here and try to color in the lines, I'm going to be here forever. Pretty sure you guys don't want an hour-long video of me just coloring. All right, now for the green equation over here, now we want above. So I want everything in green above that line. Still going to try to color inside the lines, even though I'm miserably failing. Everything is fine. We're doing great. We love pre-K. We love coloring. All right, so I'm going to try to get rid of some of this excess at least. So you can use your partial eraser and you can actually kind of clean up the outside areas if you end up doing this. That way it'll actually kind of save you some time, so you're not going to sit here and, oh no. Oh my gosh, everything's a disaster. Ugh, you know what, it's fine. It's not fine. All right, like I said, I'm not going to make y'all sit here for like the full hour and watch me like clean this up. But anyways, what we're looking for is we're looking for that area in which, you know what, just all this is going to go. Boom. So we're looking for where the areas overlap. So right here, where it's that kind of gross swamp green, I don't know how to describe it. Anyways, so where those areas overlap, that is your solution. So right here. So really, whenever you're shading, you actually don't even technically have to shade your other regions if you don't want to. Like if you don't want to color this area at all, or you don't want to color this area at all, and you only want to color the solution area, you can do that actually if you'd like. All right, so that's all you're doing for that. You're just identifying the solution area. All right, now for number 2, same idea. I'm going to use 2 different colors. All right, but if you notice, your top equation, it's already solved for you in slope-intercept form. So our slope here is 2. We have a b value of -2. And then, based on our inequality sign, this is going to be a dashed line. And because it's greater than, it's going to be above. Now for our bottom equation here, if you notice, it's in standard form. Now for inequalities, you have to convert. You cannot do the trick. The reason that is because of the shading. Because when you convert from standard form to slope-intercept form, if you have to divide by a negative, that might, ooh, English is hard, that might actually cause you to have to switch your inequality sign. So I'm going to go ahead and solve my standard form equation. So I'm going to have negative y greater than or equal to negative 4x plus 4. And this is a perfect reason right here. We have to divide by a negative 1. And for inequalities, what that means is we have to actually flip the sign. So it's going to go from greater than or equal to less than or equal to. All right, so whenever we divide by a negative 1, all that does is flip the signs. So we're going to have positive 4x minus 4. So our slope here is going to be 4, and our b value is going to be negative 4. Now for your line itself, because we can be equal to it, that means we're going to be a solid line. And because it's less than, we're going to shade below. All right, so I'm going to start with my equation in blue. So I'm going to start at negative 2 and then do a slope of 2, which means I'm going to go up 2, right 1, up 2, right 1. All right, so this is a dashed line. All right, and extend it the other direction. All right, so there's the dashed line. All right, so now I'm going to go ahead and do my equation in orange. So this is a solid line. So I'm starting at negative 4, and I'm doing a slope of 4. And this is a solid line. All right, so I want to go just like that. Okay, I'm going to extend it in the other direction. Then put my arrows. All right, now I need to figure out the shading. All right, so for my equation in blue, so I want above that line, which means I want everything on this side of the line. We love coloring. Coloring is fun. Oh my gosh, I'm missing everything. Okay, so one thing to note about notability with shading, especially with like the highlighter and whatnot, if you ever bring up your Apple Pencil and try to go over it, it's going to shade in a different color. So that's why I have to be very careful and try to get all the sections in. All right, so now for orange, we want below. So we want the other side. Of course, it wants pretty much the whole graph. So remember, we are looking for where those two areas are going to overlap. So that area of overlap is actually what I just hit right here. So the rest of this, you don't necessarily even have to color. It's really kind of up to you. Just remember the only area that we have to have shaded is the solution area. Everything else is just extra. But having all the colors on here kind of helps you see where the solution area will be. All right, so attempt to clean it up a little bit, even just a smidge. Oh my gosh. Oh my gosh. All right. I'll just leave that there. It's going to bother me. But for the sake of time, I'm going to try not to take up all the time. All right, so right here, that small little sector right here, that's going to be our solution area. That's where both of those areas overlap. So you really want to look for the discoloration where it kind of goes from clearly blue, clearly orange to kind of the mud in the middle. So we're really looking for those overlapping areas. All right, moving on. So now we're going to get into some Hoyle-Buck's problems, kind of. All right, so for this first equation, we have y less than negative x. So this is not a Hoyle-Buck's problem. It has both variables in it. So it's only Hoyle-Buck's if you only have one of the variables present. All right, so this one is the same as writing y less than negative x plus 0. So our slope here is -1, and our b value is 0. Now, based on how it's written, that means our equation here with the inequality sign is going to be a dashed line. Why am I writing that? No, it's going to be dashed and it's going to be below. All right, now for your next equation down there, we have x greater than or equal to 5. So this is going to be a Buck's problem because it's an x equals equation. So this is a vertical line. So, oh my gosh, leave me alone. 20,000 emails. All right, so where was I? Oh yeah, so we have a vertical line at +5. So let's go ahead and draw these lines. So we have a dashed line for blue. So I'm going to do that one first. So it's going to start at 0, and then just a slope of -1. So down 1 and right 1. All right, and then for your equation in red, that's going to be a solid line. Whoop, forgot to do this part. Oh my gosh. Solid line, and it's going to be above. All right, so at 5, we have a vertical line passing through that point. All right, so now we got to do the shading. All right, so for the blue line, we want everything below. So we want everything on this side. And then for our equation in red, we want everything above. So we want everything on this side. So our overlapping area between both of these is actually going to be this small little sector down here. So this little area right here is our solution. So yeah, if you want to just leave the solution area shaded, that is fine. Or if you want to do both and kind of see the overlap, that is good too. I would definitely recommend doing this actually, just because you'll kind of get a better visual of what your solution is going to look like. All right, now for number 4. All right, so for this one, so notice how we both have Hoy problems. So this is going to be Hoy for both. So they're both going to be horizontal lines since they're both y equals equations. So this is going to be a solid and below. However, your second equation is going to be solid and above. All right, so for my line in purple, I want a horizontal line at -2. And I want everything below that line, but then I want a horizontal line at +2, and I want everything above that line. So notice how if I do the shading, for example, up here, if I do the orange, it's everything above, but for everything purple, it's everything below, which means it's everything down there. So notice how this one doesn't have any overlapping area. So what that means, so no overlapping. What that means is no solution. So if there's no overlapping area, there's no solution. There's no coordinate that would satisfy both of those equations. All right, now looking below. So now we're going to go backwards. So now instead of I give you the system and I want the shading, now I give you the shading and the graph, and I want the system of inequalities in return. So you have to pay attention to the slope, the y-intercept, the type of line, and the shading. So there's 4 things. All right, so for this first one, I'm actually going to go over my axes first so we can clearly see what's the x-axis and the y-axis as opposed to what our lines are. So I've actually seen that mistake made a good amount of times. People actually confuse the x and the y-axis as equations, especially when we do Hoyle-Bucks. All right, so our 2 equations that we're going to look at, we have this vertical line here, and we have this line right here. So those are what we're looking at. So I'm going to look at this dashed line first. So we have a b value of -1. And if I look at my slope, I'm going to go up 2 and right 3. So up 2 and right 3. Now, notice how it is a dashed line and we're shaded above. So dashed and above, which means I want y greater than 2/3 x minus 1. So that's my first equation. And now for the next equation here, for our vertical line, it passes through this point 3, 0. And it's a vertical line, which means it's going to be an x equals equation. So we have a solid line, and we are shaded below that solid line. So we have a solid and below, which means less than or equal to. So that would be our system right here. So we're looking at the inequality sign, the type of line, whether it's solid or dashed, so whether we have that line underneath or not, and then we're going to look at the slope, and we're looking at the y-intercept. However, if we have a Hoyle-Bucks problem, then we're looking at if it's solid or dashed, above or below, and then if it is an x equals or a y equals equation, and where it exactly passes. Okay. All right, now looking at this next one, same idea. So I'm going to look at the dashed line first. So I'm going to start with the b value. So b value of 1. And I'm actually going to use the intersection point right here to help me find the slope. So that means I'm going to go up 2 and right 1. Go right over this 2 actually. So plus 2 plus 1, which means I'm going to have a slope of 2. So notice how it's dashed and we're shaded above the line. So dashed and above means we're going to be greater than. So slope of 2 and a b value of 1. So y greater than 2x plus 1. Then we're looking at our other equation, which is the horizontal line right here. Now that passes through the point 0, 3. And it is a solid line shaded above. So because it's a horizontal line, that means Hoy, which means y equals solid line shaded above, and it passes through the point 0, 3. So y greater than or equal to 3 is going to be that equation. So this would be your system right here.